Greetings, everyone. Today we're going to go over everyone's favorite thing in the world, factoring. I do have the foldable that we created in class that would be very helpful for taking notes. If you don't have it yet, I would just take notes on your own paper and you could fill in the foldable later. All right, quick review of multiplying. All right, I have two binomials. What's that process called when I multiply? We often use the phrase FOIL, first, outer, inner, last, or double distribution. So I've got x times x. I've got x times -1. I've got 3 times x. And I have 3 times -1. Then we combine our like terms. And we have our trinomial. Quick review, one more. Let's see what happens here. X times x. X times -3. 3 times x, and 3 times -3. Combine like terms and they actually cancel out. So what we're doing with factoring is the same process, just backwards. We're starting with the trinomial and ending up with 2 factors, or in this case, a binomial with a missing x term, and we're still arriving at 2 binomials. So keep that in mind. If you get stuck, if you're not sure if your answer is right while factoring, multiply it. See if you arrive back at the question. All right, so here's our foldable that we're going to fill out today. Yours is a little different, and mine's a little spread out here because of the screen, but make sure you're on the correct tab each time we go through the foldable. All right, let's talk about factor. What does it mean? So open to where you see this title factor. What does it mean? It means to find out what was originally multiplied to create the expression. To find out what was originally multiplied to create the expression. So essentially, if I was to really abbreviate it, we're undoing the multiplication process. Undoing the multiplication process. All right, let's take a look at greatest common factor. This should be the easiest part to remember. This goes back to our Algebra 1 days of finding our GCF. So greatest common factoring, we're looking for what is the largest number and or variables that can be divided out of every term in the expression. So greatest common factor. So, excuse me, if I take a look at example 1, I need to first decide what number I can divide out of every single term. In this case, I can divide out a 6. I'm going to show my work on this one. You can decide if you feel like you need to show it. I can't divide any variables out because 18 doesn't have one. So my GCF is 6, which leaves me with x squared minus 2x plus 3. That's it. Greatest common factoring. Quick, right? Example 2, I need to decide what I can divide out. I can divide out a 7 out of each term, and I can take at least one x out. Can't take more than one because of my second term there. So if I divide out a 7x, still exists. I'm not solving, so I need to state my GCF out front. But I have a 2x minus 1. Okay, I've got a 4th degree here, and I've got a 1st degree here. If I take 1 out of 4, I've still got 3 x's left. So don't forget that subtraction rule of exponents. And then anything divided by itself is 1. So don't just cross it off and say it's gone. I'm simplifying here. So I still need to state that one. All right, let's take a look at these 3 terms. Out of those 3 terms, what can I take out? Looks like an 8, but nope, that doesn't work. It looks like I can take a 4 out. So let's take a 4 out of each of these. And then I can take an x out, only one of them though, because of the last term there. And then I can take out one y out of each of these. So if I divide out a 4xy, I've got, let's see, 1x left, no y's left. What do we got? 28 divided by 4, looks like that's 7. I have a 4 with x to the 4th, and I have a 2 with 1y. So make sure that whatever you're left with, there's no more common factors. That's how you knew you took the greatest common factor out. All right, let's turn to the next page in our foldable to group factoring with 4 terms. So for group factoring, you've often heard it called factor by grouping. You have to have 4 terms to make this work. So the first step is to group into pairs, and then we're going to factor out the GCF of each group. Then we factor again the common factor that's left over. So we do pairing, GCF, GCF. All right, let's take a look here. What does that mean? What does that look like? So on this first example, if I group first 2, last 2, then I think of the GCF of the first 2. I can take a 2 out, and I could take an x squared out. So I have a 2x squared. If I divide that out, I end up with an x plus 6. Okay, so that's what I get when I left over when I'm dividing. Let's look at the second part. Think of the second pair as a new problem. I'm actually going to use a different color. So if I look at this second pair, I can divide out a 5, but then also notice your signs, that negative matters. So if I divide out a negative 5, I have left over an x and a positive 6. Okay, so watch those signs. Your goal in group factoring right here, though, is to get the same thing twice, because guess what? There's your next common factor. If I divide out an x plus 6, if I take both of those and divide them out, that looks like this. Then what do I have left over? Left over, I have a 2x squared and a minus 5. The 2 terms that I factored out the first time. Okay, let's try another one. So group the first 2, group the last 2. You'll notice these are in standard form. In general, you want standard form. Doesn't have to be always, but that makes it a little bit easier. So my first GCF is 2x squared. If I factor out that 2x squared, I have an x plus a 2. And on my second set, I don't see anything actually, but you have to take something out. So you can always divide a 1 out, and it would be positive due to my sign. So if I divide a positive 1, I still have x plus 2. Okay, so now when I look at that common factor, let's divide it out. And what do I have left over? A 2x squared plus 1. That's why we need the plus 1, because if I didn't have that, I'd just have a monomial times a binomial. I wouldn't end up with these 4 terms if I multiplied them back out. All right, and the third example, I've got my first 2 terms and my last 2 terms. Okay, this time we've got, it looks like oops, let me use my purple. It looks like I have a 3, an x, a 3, and an x. If I divide that out, I would have a 4x plus a 3y. And then on my blue, I gotta take a sign out for sure. I could put a 1 if I feel like I need it, and then I can take a y out. If I divide out a negative 1y, I have left over a 4x, a negative divided by negative is a positive, and I'd have a 3y left over. So if I take a look, if I tell you to do grouping, you should always end up with the same factor to divide out. If I divide out a 4x plus 3y, I have a 3x minus 1y left over. All right, factoring trinomials. All right, you guys, there are a lot of ways to factor 3 terms. There's a lot of methods that we can go about this. As teachers, we've gone back and forth, you know, when should we teach this method? When should we do this? But because we're on the enriched track, your goal is calculus. So we really want to try and utilize guess and check method, to be honest. We want you to be able to use that mental math to execute factoring. We want it to be a smooth mental process. So with that in mind, if you've learned a different method that works for you, you're welcome to keep using it, okay? If you struggle with what we're doing and you feel like a different method might help, then we need to visit one-on-one, or you could visit with a math teacher in the Sabre Center and ask for another method. So first of all, start by writing two sets of parentheses, okay? So I'm going to do an example as we go through these steps. So my first step says write two sets of parentheses because I'm going to have a binomial times a binomial. Second step, what two factors multiply to make the first term? Okay, I'm going to use some color association. So blue, blue. X squared, well, that's easy to break apart. That'd be x times x. What two factors multiply to get the last term? So in green, the last term is 6. I have a couple of options here, right? 6 could be 1 times 6 or 2 times 3. Okay, so here's the thing. We have to try different combinations until we receive the original problem. So let's think about that. I should end up with an outer and inner, if I multiply, that get me to 7. So because my leading coefficient's 1, only when it's 1, can we then look and say which of these two numbers, or which of these two sets of factors get me to 7? And in this case, that'd be 1 and 6. Sign-wise, everything's positive, so we'll keep it positive. So if I take a look and I think about first times first, last times last, outer, inner, I would get to 7. So these would be my two factors. Let's try this process again. First, write two sets of parentheses. Parentheses, 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 parentheses. Second, write two factors that make the first term. Well, again, it's x and x because it's x squared. What two factors make the last term? This is a negative 16. So I have to have a positive negative. And I could have 1 times 16, 2 times 8, 4 times 4. Those are all my options. So mentally, let's go through that process. If I need to get a middle term of negative 6, well, 16 and 1 ain't going to get me there. 2 and 8 might, 4 and 4 won't. So I've narrowed down my options to 2 and to 8. But they need to be opposite signs, and I want a negative 6. Because this is negative, negative 8 plus 2 gets me to negative 6. Positive 2 times negative 8 gets me to that negative 16. So you're almost thinking about that multiplication just a little bit backwards each time. Let's take a look at one more. First, draw your two sets of parentheses. Second, what factors multiply to get your first term? Uh-oh, we've still got the x's, but now we've got a 3 and a 1. 3 and 1. So what two factors make up the last term? Well, positive and negative and a 1 and a 2. Those are my only options, okay? But I have to decide because I have this leading coefficient, you guys, that changes things. So to be totally honest, here's how guess and check sort of works. Let's just plug in a 2 and a 1 and some different signs and see what happens. If I multiply this back out, I'd get 3x squared minus 3x, positive 2x minus 2. That would get me to 3x squared minus 1x minus 2. That's not good. This negative doesn't exist in the question. So I need to change something around. So this time, why don't we try just changing the signs? What if this is negative and this is positive? Check that. Then I'd have a 3x squared, a positive 3x, a negative 2x, and a negative 2. Would that get me to the positive 1x? It does. So a little bit of guess and check. It doesn't take long. Some of you might know the box diamond method, you might know the area model, whatever you call it. To do that process takes just as long as making these couple guesses. So time-wise, if you get those mental guesses going, it actually makes the process quicker. All right, let's take a look at a couple more challenging examples and we'll walk through the same steps. So first step, create two sets of parentheses. Second step, what two factors make your first term? Well, I definitely have an x times an x, and the only factors of 5 are 5 and 1. What two factors multiply to get the last term? Oh, I got a lot of options here. I'm going to have a positive and a negative if it multiplies to be negative. And the factors of 18 are 1 and 18, 2 and 9, and 3 and 6. So I kind of have a lot of options there. So here's where mentally thinking through that backwards FOIL is going to be helpful. If I think of outer is going to be 5 times something, and it's going to get me something. Inner is going to be 1 times something to get me something. But when I combine like terms, when I combine these two, I get my middle term of -1. They almost will cancel each other out when I combine them. So that means the totals have to be very, very close. That narrows it down, you guys, just thinking through that. Because 18 is way too much of a difference from 5 to ever get a difference of 1. 3 and 6. Well, 5 times 3 is pretty big. 3 times 5, excuse me. Yeah, it's a possibility, but let's take a look at 2 and 9. If I take 5 times 2 and 1 times 9, whoops, that's a 9. I was thinking ahead, sorry. That's really close to 1, right? So I've already made some just guesses. So I think that I should take outer is 5 times 2, and I think inner should be 1 times 9. Sign-wise, though, I need a difference of -1. That means the bigger number, outer, is bigger, should be negative, and the inner should be positive. Here's the thing, you guys. If you're unsure, just plug in signs and FOIL it out mentally. If I do a quick FOIL, first would be 5x squared. Outer would be -10x. Inner would be 9x. Last would be -18. -10 plus 9 is -1. I'm back to the original quadratic. So I know I'm right. So every factoring problem, you guys, you should ace on a test because by re-multiplying, you know if you're right or not, okay? So it required more guess and check because the leading coefficient of the first term was a bit bigger, okay? So when you have that, it's going to take a little more time. That's the expectation. All right, the second example on this page, but example 5. First, set up your 2 parentheses. Oops, gotta cross that off. I wanted to keep my colors, so that's not gonna really match, but I wanted purple. My first term, oh goodness, 30x squared y. So I know I'm gonna have an x and an x, and I know one of them is gonna have a y, but the factors of 30, oh man, I've got 1 and 30, 2 and 15, 3 and 10, 5 and 6. I got a lot of options here. So let's take a look at the last terms. The last term's 30y. So one of those is going to be a y. But which one? Does it matter? It kind of does, right? That last term matters the order. 30. Oh my gosh, I got 30 again. 1 times 30, 2 times 15, 3 times 10, 5 times 6. And here's what I'm going to do, guys. I'm going to leave you hanging here because I want you to struggle through this and work it out, okay? So keep working on this. Keep trying it out when you got extra time. More importantly is going to be the basics. Ones with these numbers are going to be a little more important as we get started. But I want you to still work on the process for example 5, okay? Keep trying. All right, let's take a look at the last page, difference of perfect squares. Let's go through a few steps. First of all, identify if you have each of the following. You need a difference. What does that mean again? Oh, difference, that's the operation of subtraction. You need a subtraction problem. You need a perfect square. What's an example of a perfect square? That's going to be x squared. That's going to be 1 times 1. 2 times 2, 3 times 3, 4 times 4, 5 times 5, and so on. So those are all perfect squares. You could even say y squared, right? Any variable squared. Or I could say x to the 4th. I could say x to the 6th, okay? All of those I can square root, if you think of it that way. Okay, the second major step is then use it to factor it into two factors, one positive and one negative. Let me backtrack. Let's go back to the very beginning for a quick second. I'm just going to write this to the bottom. You don't need to write this down. Remember when we had x, something like x minus 5x plus 5? If we multiply those out, we get x squared minus 5x plus 5x minus 25. Outer and inner went away. We had x squared minus 25. Look at the pattern. X squared became x and x. 25 became 5 and 5. And because there was no middle terms, because they canceled, we had a plus and a minus. Look at how that works out nice and even. So these go quick and you don't even need to show work, you guys. 2 parentheses. Okay? Factors of the first term. Factors of the last term. Because it's perfect square, they should be the same. And because it's difference of squares, you need to have 1 plus, 1 minus. Let's go through the rest of these quick. 2 parentheses. First term, perfect square, perfect square. 9, perfect square. Perfect square would be, oh, where's my pen? 3 and 3. And the difference is positive, negative. Let's go once more. Parenthesis, 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 parenthesis. Factors of the first are 9 and 9. Factors of w squared, ww, plus minus. Okay, you get the hint here. So I'm going to, these are sort of the easy ones, you guys. I'm going to have you finish example 4. Oh, let's take a look at example 5. Parenthesis, parenthesis, that looks good. I'm going to have a 2x and a 2x. That makes sense for 4x squared. Then I have a 7. 7 is not a perfect square. Nothing works. So this is an example of not factorable. Okay. Take a look at example 6. You guys, 5 isn't a perfect square and 20 is not a perfect square. But let's take care of GCF first. If I look at the GCF, I can divide out a 5 and I get x squared minus 4. Hey, now that works. Keep the 5, but now set up your 2 parentheses. Factors of your first term, factors of your last term, 1 positive, 1 negative. Okay, so the only difference was I just had to take something out first to make it work. All right, let's do GCF for this one too. I've got a 2 and an x I can divide out. When I do that, I'm left with x squared and a minus 36. There's my GCF. Then I can start factoring. 2 parentheses. Then we'll have my first terms, xx, and my last term, 6. Different signs make outer inner go away. And then don't forget to bring down that GCF. That's considered a factor. So this actually factors 1, 2, 3 times. All right, I know that was a lot, you guys. Thank you for bearing with me. Rewatch some of this if you get stuck. You've got a couple left over to finish on your own. If you have questions, make sure you see me. And in next class, we'll continue working on some more factoring. So at this point, just pay attention to when the next learning check is. Check to see what homework's due or if you have any fixes, anything to work on. And then make sure you always keep up with Google Classroom to see what you need to do. Alrighty, have a good one.